In problem AD chapter 3, we have this mass which is sliding on this bar after applying force P on it. At the beginning, the mass is at point A, and we are applying P force to it, which is always going to be in this direction, 35 degrees from the horizontal direction. And we are asked to find the velocity at point B. And there is no friction between the mass and this bar. We have two cases. In the first case, the force is going to be 25 Newton, and in the second case, force is going to be 40 Newton. In the first case, we are not going to have any motion, and I'm not going to prove it here for you, and you can think about it yourself. It's pretty easy. So there is not going to be any motion if we apply 25 Newton. Actually, the weight is going to be more than P times sine of 35. That's why. In the second case, I'm going to use working AJ equation to solve this problem for you. Because we have gravitational force here, we need to put a reference line to measure gravitational potential energy. And let me write the equation first. T1 plus V1 plus U prime from 1 to 2 is equal to T2 plus V2. So at the beginning, there is no velocity, so T1 is equal to 0. There is no kinetic energy at point A. And V1, because the mass is on the reference line, the height is 0, so there is no potential energy too. To calculate U prime from 1 to 2, we need to see, do we have any non-conservative force? Which we do. We have this external force, and also we have normal force between the mass and this bar. But the normal force, because it is always perpendicular to the trajectory of movement, it's not going to do any work. So the work of that one is 0. But the work of this force P is not equal to 0. Force P always have a component, force P has always the component in the x direction, which is equal to P times cosine of 35. And also it has a constant component in the y direction, P sine of 35. Based on the previous lecture, U prime 1 to 2 is going to be the force in the x direction times displacement in the x direction. So it's going to be P times cosine of 35 times displacement in the x direction is 0.8 plus the force in the y direction times displacement in the y direction, which is P sine of 35. That's the component of the force in the y direction, and the displacement is 1.6. So that's going to be U prime. And at the end, T2 is going to be 1/2 of mass times velocity at this point squared. And also the potential energy is going to be mgh. So h is 1.6, so 1.6 times m times g. M is given, m is equal to 2, and g is 9.81. So if you put everything here, the only unknown is going to be the velocity at point B, which we called it V2 here. And from there, V2 is going to be 5.62 meter per second.